We need to find the voltage drop V1, V2 and V3 in this circuit. So we will apply KVL. There are several elements and the voltage drop of the other ones are given, but it's not said whether it's their passive or active elements, and it's not needed because we know the drops and we can apply Kirchhoff's voltage law to find the unknown voltage drops. So first we will have to choose loops correctly. So let's first try to find V3 and let's choose this loop. So this one, I will draw the loop, the outer one, like that. So this loop, and let's travel in the counterclockwise direction, and let's write the drops as maybe negative and rises as positive. So when we move in this direction, in counterclockwise direction, V3 is a rise, so that's positive V3. Then 30 volts, this one, that's also a rise, so plus 30. Then we have 50 volts, this one, which is a drop, so minus 50, and 40 volts, the last one here, is also a drop, so like that equals to 0. Sum of voltage drops is 0, but anyway we have written the drops as negative. I could have done drops as positive. I prefer writing drops as positive, but whatever. So here what we get, V3 to be 90 minus 30, so that will be 60 volts. So we now know what's the value of V3. So now we have to find we have to choose another loop. Let's say we choose this loop now, like that. So for that one, V1 is a rise. Now let's write the rises as negative. So V1 is a rise, so that's negative V1. Then we have 20 volts, that's also a rise, minus 20. And then we have 50 volts, this one, because this is the loop. 50 volts is a drop, so that will be positive. So drops are positive and rises are negative in this equation. So finally 40 volts, that's also a rise, a drop, so positive. So we get V1 plus 20 equals to 90. So V1 is equal to 70. Now we have to find, we have found V3, we have found V1, we need to find V2. So we will choose another loop, and let's do this loop like that. So V2, 30 volts and 20 volts, those three. So now V2 is a drop when we go in the counterclockwise direction. So V2, then we have 30 volts, which is a rise, so minus 30. And then finally we have 20 volts, which is a drop, so plus 20. That's 0 here. So V2 becomes 10 volts. So this is 70 volts and this is 6 volts. So we have now V1 as 10, V1 10, V2 70 and V3 60. We can do a check by applying KVL in this loop and see if it satisfies. So if we go like that, and our here we are going in the counterclockwise direction, so V3 is a rise here, so I will write negative, rise negative. Then I'm again writing rises as negative. Just in this first equation I wrote rises as positive, but whatever. So we have to be consistent in one particular equation. Usually it's better to be consistent everywhere so that the marker doesn't get confused. Anyway, so that's minus V3, then minus V2 because that's also a rise. Finally plus V1, that should be equals to 0. So we have V1 10. V1 is 10 or what? V1 is 70, sorry. V1 is 70 here. I don't know why, what did I write there? V3 is 60 and V2 is 10, V2 is 10. This one, V1 is 70. So we have 70 plus 70, and then V2 minus 60, and V2 minus 10. Once again, V2 is 10, so minus V2 is minus 10, and V3 is 60, so that's minus 60. So it satisfies minus 60 minus 10, which is minus 70, plus 70, which is 0. So it satisfies. So that's there. So we can always do a check considering another loop. Particularly in this case, we can do the check.